So for number 10, if you notice, before we start solving, we're supposed to do any cleanup, right, that we can do. Isn't there some cleanup to do on number 10 on the left-hand side? There's some like terms. Kaylee?
You have to put the X on the...
Right. Well, they're kind of on one side, but you got to get them together, right? You need to combine them. We could add like terms here. And here's what's kind of weird about it. You got a fraction and you got a whole number, but remember, these two variables are the same. They both have an invisible 1 exponent, so they got the same exponent. We always have to check the exponent too. But I can add them, and what I do to add them is I write the like term down, and a lot of you may remember I had trouble with this on the test. You kind of got the rules all mixed up. We write the like term down, the x down, and we add the numbers out front. So let me go to the side. What is 4/5 plus 2? Well, you know, the easy way to do that, isn't that 2 and 4/5, right? Okay, so now, can't I get this? It's not handy to work with it. I can put 2 and 4/5 x equal 14, but do you see how that's not very handy to work with? What you going to do with it, you know? That's why we don't like these mixed fractions. But I can fix that because that's why you spend all that time in elementary school learning how to do and undo these things. Remember, you would say 5 times 2 is 10, plus 4 would be 14 over 5. Oh, I want to write it as 14 over 5x equal 14. Kind of a good example of why those mixed numbers aren't very helpful. How do we undo that, you know? Can you divide each side by 2 and 4/5? Well, that'd be a real big mess. And usually algebra, there's ways to make it easy so you don't have big messes. I'm not saying it doesn't get messy, but, you know. Now, if here's my x, how am I going to get that x by itself? It's multiplied by 14 over 5. We would normally say divide by 14 over 5, except that's even messy. So what's the quick way to take care of this? What am I going to do to both sides?
Multiply by the reciprocal.
Yeah, multiply by the reciprocal. So we're going to flip 14 over 5. That will become 5 over 14, and it's so wonderful. It is so wonderful what happens next, because look. 5 goes into 5 once. 5 goes into 5 once. 14 goes into 14 once. That's why we do it. It made everything go away. We're always looking for things that make all of our problems go away. And in math, it's kind of easy, unlike life. So 1x is just x, right? Is that the truth? In math, we got easy ways to take care of it. Life, not so easy. All right, now what's going to happen on the other side with those 14s?
The 14s would cancel each other out, and you would have 5.
Yes, this is going to be 5, isn't it? So if you have trouble doing that, remember you can always make both of them a fraction, and sometimes your brain sees what Chester's saying there a little bit better. You can cross those out. Oh, 14 goes into 4 one time. 14 goes into 14 one time. 14 goes into 14 one time. It's just everything canceled out but the 5. Da-da-da. You're done. Now, one of the things they're doing here is messing with you a little bit. They're giving you fractions, and that usually freaks everybody out. But the other thing you got to notice is, don't you have x's on both sides? And when we're solving equations, we got to get all the x's together on one side. So first thing I'm going to look, is there anything I could clear up on the left-hand side, just looking at it? Can I combine 2/3 x and 4? I should check that first. They're not like terms because the 4 doesn't have an x, does it? So can't really clean the left-hand side up. Go to the right-hand side up. Same thing. I can't clean that up either because I have an x term and then I have a number. So those won't squish together, even though I'd like for them to maybe. So I can't really clean anything up. There's not really any simplifying to do, but before I start solving, here's what I can do. I can move the x's to one side. Which is bigger, 2/3 or a half?
Half. 2/3.
2/3, right? A little bit bigger than a half. So I'm going to take the half and I want to move it over to this side. How do I move it? If you remember, Lazy Math Guy doesn't write this, but he could have put a plus in front of the 1/2 x. And if he had it would solve people's problems a lot of the times because you just don't think that you can move it sometimes. But it is a plus 1/2 x. Couldn't I move it by adding the opposite thing? Remember, I can add things and move them from side to side as much as I want to. Don't usually want to do it very much, though. I could say the opposite of a plus 1/2 x is a minus 1/2 x, and I can move it to the other side. The reason I picked a minus 1/2 x is 1/2 x minus 1/2 x is 0. And 0 plus 5 on the right-hand side is just 5. We can add opposites all day long and move things up, back and forth from side to side. We just got to be careful that we don't just get caught up in doing that for no reason, right? So now on this other side, I have these x terms, and I need to subtract them. Remember, since I've got like terms, I'm going to write my x down. I need to think, well, what's 2/3 minus a half. I'm going to do it this way because sometimes people like to do it horizontally. I'll do some of both ways just to accommodate everybody. My common denominator would be what? 6. So this 2/3 would need to get multiplied by 2 over 2, and the half would be multiplied by 3 over 3. And so I would have 2 times 2 is 4 over 6, and then 1 times 3 is 3 over 6. 4 over 6 minus 3 over 6 is 1 over 6. So I have 1 over 6x, and then I've got that plus 4. I got to remember to drop it on down. And so here's the real equation I got to solve. I had to do all that before I can even get to the point where I need to think to do PEMDAS backwards. I got to get all the x's on one side, and I finally did. So now, all that work later, I can finally start to think about doing PEMDAS backwards. I want to get the x by itself. Here it is. What am I going to do first? Focused on that left side where the x is.
Get rid of the subtraction 4.
Yeah, we're going to get rid of the 4 first because it's plus 4, so we can say I can subtract it. We always do the opposite to get rid of something. So that would 4 minus 4 is 0. And so I have a 6 times x plus 0 is just going to not matter. And 5 minus 4 is 1. Is the x by itself? Nope. What am I going to do to get it by itself? I could divide by it.
The reciprocal.
Or, yeah, if I want to make my life easy and not be like screaming when I run out of math class, I'm going to remember that I can multiply by reciprocal and it will make my life so much easier. Because look at that. All the 6's cancel out. They really turn into 1s, right? It's not like they really just disappeared from plain sight. They turn into 1s. But we've talked about how 1 times 1 on the top is 1, 1 times 1 on the bottom is 1, 1 over 1 is 1, and 1x is x, okay? And then you got 1 times 6 basically on the other side, right? Because 6 over 1 is just 6. 1 times 6 is 6, da-da-da, you're done. I'm doing number 7, okay, on the worksheet. Is that not y'all's worksheet?
No, it's our worksheet.
I know we hadn't had negative numbers yet, but I want you to think about this. First of all, there's no simplifying to do here because even though there's 2 terms on the left side, one's got an n in it and the other one doesn't, right? Here's what you can do here, and you don't even really have to think about negative numbers. What's the opposite of a minus 9? You can actually, a plus 9. You don't even have to think of that so much as here. A minus 9 and a plus 9, you know those are opposites of each other, so you're going to do that to both sides, okay? I'm going to do that. Because aren't those just going to add up to 0? So even if it does say negative 9, yeah, it is a negative 9. But what you're going to start finding out is that we can think of negative 9s and minus 9s the same way, okay, if they're the same number. That would just leave me with 0 plus n over 4 on this side. Now, aren't I adding minus 7 plus 9?
Yes.
And you might be thinking negative 7 plus 9, and you're right, it is negative 7 plus 9. But when I add two things, doesn't the commutative property say I can switch them? Okay? I could literally, I could write it that way if I'm being all particular. But when you add a negative, do you remember that that's just mathematicians came up and go, ooh, I don't like doing that, so I just write a minus sign because I get tired of putting plus and minus. What is 9 minus 7?
2.
You could actually read that as 9 minus 7 is 2. You could actually read it that way, okay? So that's some of what we're going to talk about when we get to negative numbers, is you're going to notice that we play really loosely with the subtraction sign and turn it to a negative sign and vice versa, okay? And you could say 9 minus 7 is 2. Ooh, that problem was just solved, right? The little issue we had with that now. Now what do? You want n by itself. What's happening to n? It's being done. What's being done to it? It's being divided by 4. What's the opposite of dividing by 4? Multiplying by 4. There we go. So I'm going to multiply both sides by 4. Problem solved. It cancels out. Remember, I could put a 4 over 1 if I need to. And it cancels out, and I just have
Nate.
it equal 8. Nate, okay. It equal 8. Okay, so on this one, if you look at that left side, there's a couple of terms with r's in them, right?
That's not.
Now, I'm going to show you a little math trick that's really cool to know. Remember how I told you proportions show up everywhere, right?
Yeah.
I have a fraction on one side. It's just a fraction all by itself. On the other side, I have a negative 7. Could I turn it into a fraction?
Yes.
And if I did, wouldn't that be a proportion?
Yes.
It would be. Okay? I could do this. I could say, anytime I see one side that's just a whole fraction, I wouldn't want to have a fraction plus a whole number and do this. It's only when you got a fraction on one side and then a number on the other. Let me put it over 1 and let me cross multiply. 1 times anything is just itself, isn't it? So 1 times k minus 10 would just be k minus 10. And again, this is a little bit above what we're doing right now, but that's okay. I think you can learn something from it, and then when we get to it again, I'll carefully go over what would we do. Now on the other diagonal, remember when you do proportions, you just cross multiply. 2 times 7 is 14, and if you didn't know it, a positive times a negative is a negative. So it's good that we're working this one together. Sometimes I look at this and I might do it a little differently. I don't think about it so much as being a negative, but here, if we're going to work it this way, I have to look at it that way. All right, so I got to get the k by itself. Wouldn't be the opposite of a minus 10 would be a plus 10. Okay, yeah, this one ended up with a negative, and I didn't really realize it. Now, think about those counters we used when we were playing around in class. Negative 14 would be 14 reds, wouldn't they? It would be like 14, 1, 2, 3, 4, 5, 6, 7, just a second. These would always,
Potatoes.
let's say those are all red dots, okay? Those are red dots. And they're red counters, okay, like we did when we did equations. And then let's say I made 10 yellow. So if you remember, for every red that has a yellow with it, they'll cancel out. So that cancels out. There's a pair 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 that cancels out. Another one and another one. How many are left? What color are they?
Black.
Red. They're red. They're supposed to be red. I should have drawn them red, but I didn't. So there's 4 reds. That's a negative 4. Okay? So it's kind of good. We're playing around with negatives before we even get to them, but you can kind of think of them because of the counters. If I'm looking at this problem, I can make it a proportion because I got a fraction on one side, I got a whole number on the other. Can't I just stick it over 1? Okay? And I can cross multiply. 1 times anything is just itself. So when I multiply 1 times minus 5 plus x, I get minus 5 plus x. And then when I multiply 22 times negative 1, 1 times 22 is 22, and a positive times a negative is a negative. And yeah, I know you don't know that yet, but that's okay. We're just going to go through it together and learn a little bit.
A negative times a positive is multiplication.
Okay, we're really sure we won't use that, okay? So here's the x. Got to get it by itself. It has a subtract 5 in front of it, right? Can I add 5 to both sides? Okay, so that would be 0 plus x is x. Now, if you think about this, if I had 22 red counters and 5 yellow counters, 5 of the 22 red counters are going to cancel out with the 5 positive ones, right? Wouldn't there be 17 reds left over? If you actually did that, if you can imagine doing that, because 22 minus 5 is 17, basically. But if I had the counters out, I could literally cancel out 5 of the 22s there, because there's more of the 22s. There would be 17 left over. Yeah, and they would be red, so it would be a minus 17. And that's how I could do that without actually having covered negative numbers technically, because we've used those counters. You could actually kind of figure this one out by thinking about those counters.